Hi, everyone. Like Liz said, my name is Arup Chakrabarti. It's phonetic, if you want to pronounce it later. And I'm here to talk about our multi-cloud journey at PagerDuty over the last 5 years. Official title of my talk is 5 Years of Multi-Cloud at PagerDuty, a romantic and very complicated love story. And I have my Twitter handle on all my slides, so if you want to give me feedback throughout the talk, feel free. I'm going to take off my watch so it doesn't keep buzzing the whole time. And also, if you have feedback after the conference, again, feel free to reach out to me on Twitter. I'd be happy to answer questions after the talk as well. So first, my clicker could work. There we go. Some disclaimers and context that I want to lay out before we get into the meat of the talk. So first, what is PagerDuty? Who here has heard of PagerDuty before? Oh, fantastic. I don't have to do anything. Great. All right, so skipping to the next slide. The first thing is I work with very smart people, and I'm very lucky and privileged to work with the engineers that I get to. And so while I'm up here talking about a lot of the concepts and work that we've done over the last couple of years, I didn't do all of it. Hell, I didn't even come up with most of it. So I'm speaking on their behalf here, and I want to make it clear that I did not come up with all these ideas. Again, I work with really, really, really smart people that are much smarter than me, and I have the privilege of being up here and talking about the work. The other thing is, you are not PagerDuty. If there's one thing that drives me nuts about certain conference talks is the idea of cargo culting ideas and saying, well, this goofus at PagerDuty said we should do this, and so we're going to do that. No, that's absolutely not what I want for any of you to take away. At PagerDuty, we have distinct advantages and disadvantages to our business that we leverage, and just every single one of you, same exact deal. You have advantages, constraints, disadvantages that you have in your teams and your environments at your companies that you get to leverage as well. So what I do want you to do is listen to the talk, think about it, contextualize that information, and if you think there is something relevant, then bring it back to your organization. Please don't just copy pasta my ideas back into your organization, because I guarantee you it will fail, and quite frankly, that's not what good leaders do. And also, we get this wrong too at PagerDuty. For us, we find that every 6 to 12 months, we have to go back and challenge some of the assumptions we had, because what worked for us 12 months ago probably isn't going to work for us today, and what we need to be doing 12 months from now is fundamentally different from what we do today. So we get this wrong too. So please don't take any of this as gospel or dogma. These are just lessons learned and things that we figured out over the last couple of years. Also, you will not get an easy answer as to how to do a multi-cloud environment from this, but I'll give you some things to consider. And lastly, this is not a vendor endorsement. I'm going to be focusing mostly on Amazon Web Services and Microsoft Azure today. That's what we use at PagerDuty. I'm actually going to be making fun of both of them equally. So, but more seriously, like I do get this question every now and then of like, oh, which one should I use? And again, it depends on your environment. If you're a .NET shop using SQL Server, Azure probably makes more sense for you. If you want crazy control over every little thing in your environment, maybe AWS. If you want less headaches to deal with, GCP has done some amazing work in the last 12 to 18 months, and there's a whole swath of other players out there that are doing great work too. So please do not take away like, oh, only use the two providers that I'm talking about today. That's not what this talk is about. And then, of course, slides will be posted afterwards, so if you don't get a picture of something, don't worry about it. It'll all go on speaker deck after later today. All right, so some more context. So terminology. When I say multi-cloud, what do I mean? From my perspective, it means having active or passive infrastructure running in multiple cloud providers at the same time. And the other piece here is that you have the same product or service spread across multiple cloud providers. And the reason I say this is what a lot of companies do is they'll be on a specific provider, say, a very common journey I see is they're in their data center environment, they create some sort of open pass or something and to create an internal cloud. Then they rewrite stuff, they put it into a public cloud. And to me, that's not multi-cloud because you're rewriting the service. And look, to be clear, like I'm a big advocate of doing that when you're making those kinds of changes. But to me, that's not multi-cloud because you're not running the same set of services across the two different cloud providers at the same time. This is also something every procurement manager thinks they want. It's hilarious. When we first started to go multi-cloud at PagerDuty, our head of procurement at the time, we were only spending a couple $1,000s a month on each of our providers, and our head of procurement comes to me and says, Arup, this is great. We can finally leverage them against each other. And I had to tell her, unfortunately, Amazon or Microsoft, they don't care about us at this point. We're way too small for us to get any discounts out of them. We're going to have to pay list price for the time being. And every procurement manager thinks this is the best thing in the world, and at a small scale, it really doesn't matter. Another set of terminology, active-active. So what do I mean when I say active-active? It's running the same workload across multiple data centers. So the idea is that every single data center you have can take in requests and serve those requests. From a customer standpoint, you can get redirected to any of them. Doesn't matter. Distributed systems, whatever that means, but that's another common term used in active-active setup. Active-passive, from my perspective, it's running a workload in one data center with a standby data center. So you're running MySQL in a master-slave topology, and the primary data center goes out. Great, you fail over to the secondary, promote that to a primary. That's a good example of active-passive that I'm sure many of you are pretty familiar with. So let's lay out a history lesson and go back so I said 5 years. When I submitted this talk, it was 5 years ago. Now it's about 5.5 years. So let's go back to 2012. So PagerDuty in 2012, interestingly enough, we are a cloud-native company. We launched in 2009, and our service has always been hosted on some cloud provider. We never had any colos or any hardware that we ran ourselves. We launched on cloud providers back in 2009, and in 2012, we still had the same kind of setup. We used failover for achieving high availability, so this was based on MySQL master-slave topology based on DRBD. We can get into a debate about DRBD later. And then we had a stateless Rails app with a bunch of load balancers in front of it, pretty straightforward to scale those things out. And we had AWS US East 1, that was our primary data center, and we had a failover site in New Jersey. So my very accurate map that I've drawn here, this is this is what happens when you search green outline of the United States in Google, and it just works. So this is what we had. This was our primary was the green dot there, and the secondary was the red one. And then we started to see more things like this happen in 2012. So if you think back to 5, 6, 7, 10 years ago, the cloud was this very weird technology. No one really understood it, and it was plagued by reliability issues. And you repeatedly heard from many CIOs and technical leaders that, yeah, if you're some rinky-dink startup, fine, you can move to the cloud. But real companies, they don't do that. They have their own data centers. They run their own infrastructure. And it also didn't help that this was very common in the news. All I had to do to search for these articles was go into Google News, search cloud unreliable 2012, and I got about 70 articles with citations pointing to very public outages from many of the cloud providers out there. And then this happened. I'm sure many of you have blocked this out of your memories, and I can't blame any of you for doing that. But this was probably one of the most prolific outages that AWS had in the summer of 2012, and this affected PagerDuty, and correspondingly, we had our own outage as a result. And quite frankly, we didn't meet our customers' expectations that day, and we weren't able to fail over quickly enough to our secondary site. We had an outage. We did a bunch of work to figure out, what could we be doing to get better at this. But the main message in 2012 was the cloud is unreliable, that it's something that if you want to achieve reliability, you don't use the cloud. That was the main message we kept hearing from the tech press back in the day. So to us at PagerDuty, minutes of downtime is unacceptable. So if we want to achieve reliability, the only way to achieve that was through distinct regions. And that was kind of the mantra that a lot of companies were talking about in 2012 was you can't be hosted in one region if you want to be reliable. And I also think that to this day that there was just a talk about this about an hour ago from Jet. They talked about the same exact thing where if you want to achieve reliability, you need to go multi-region. So late 2012, this is after that outage I was talking about, we started to tease apart the main PagerDuty product into services on the back end. And what we started to use was more quorum-based systems. So things like Cassandra and Zookeeper were two core technologies that we use. This idea that majority writes wins or majority reads wins, not having full synchronous behavior between all of our data stores. We also favored durability over performance. And what I mean by that is, for PagerDuty, if you get a 200 from when you send us an event, that means that we've persisted that event to at least 2 distinct regions. And that's slow. That is really slow to do that. But for us, we said that was okay because from our customers, we were hearing, look, if I send you something PagerDuty, I need to make sure you have it, and you're not going to drop it. It's never going anywhere. And so we said, okay, we'll make things a little bit slower, but we'll make sure we never drop anything. We still needed regions or data centers within 50 milliseconds of each other. We did a bunch of testing with a bunch of different providers and found that after 50 milliseconds, the software was getting just simply too complicated to run, especially things like Cassandra really struggled at the time on, I think it was version 1.2, really struggled if you had beyond 50 milliseconds of latency. And so our first stab at this was using AWS US East 1, West 1, and West 2. So again, very accurate map of the US. This is kind of what it looked like. But there's that 50 millisecond requirement that I just mentioned. So what happened? Those are turtles, by the way, red turtles on my clicker, my laser pointer's not working. So we set this up, and it completely fell over. It didn't work at all, and it was because there was about 100 milliseconds of latency between US West 2, which is based out of Oregon, back to US East 1, based out of Virginia, and even from US West 1, which is based out of probably down the street here in San Jose, over to US East 1. That didn't work either because that was 75 milliseconds of latency. Again, a lot of our systems just kind of fell over when we kept it running for a few hours. So we had to figure out, okay, how do we accomplish 50 milliseconds of latency across 3 data centers? And so for us at PagerDuty, we had to go multi-cloud because of our latency requirement. And that was something that was very conscious and deliberate that we said, hey, we're going to take on this additional complexity because we needed the 50 milliseconds of latency. So this is what we landed on. AWS West 1, West 2, and Azure on the West Coast. I believe based out of Fresno, California, and things were nice and fast. About 20 milliseconds between the Oregon and California data centers, and it was really nice to have about 5 milliseconds of latency between AWS and Azure in California, and those are nice speedy rabbits that you can see now. So again, 5 years later, where are we now? Right now, we have software deployed across AWS West 1, West 2, and Azure Fresno. We have about 50 services on our back end deployed across, spread across about 10 engineering teams. And each team owns their own vertical stack. We're a big proponent internally at PagerDuty that you build it, you own it, you run it. And what that means is, and all of our engineering teams, they own their own load balancers to the application stack, to the servers that run those applications, even down to the databases. So let's use some post-mortem-y language here. So what went well? What did we get out of this? Well, the first was the reliability benefits. That was the original intent that we were going after here, and we actually did achieve it. Here's a handful of, again, I just searched cloud outage, and here's a handful of events that we never noticed at PagerDuty because that's just how our infrastructure was set up, and that was kind of nice to get that validation that, oh, hey, US West 1 had some networking blip. And we didn't notice because that's exactly how the system was designed. Same thing with the other providers as well. Again, they'd have some small blip here or there, and our customers never noticed. One gotcha though that I think was something that I wish I'd been more mindful of back then though was we were measuring reliability from the standpoint of the absence of events, and you've probably been to a couple talks today. That's a really dumb idea. That's not actually how you measure reliability. So we would look for things like, oh hey, there was an incident in this provider and we weren't affected by that. And honestly, that's kind of a dumb way to measure reliability. Again, so we ended up settling on kind of a more traditional SLO approach towards measuring our reliability. Portability benefits. This was an interesting one where we are able to migrate infrastructure between providers on an as-needed basis. So one interesting thing for us is we boil everything down to just compute. And again, all these providers have all these higher level abstractions and everything, but to us, all we use is either EC2 or the Azure Compute product, and that's it. If we can spin up an Ubuntu image, we can secure it and use it, and we don't need any other tooling around it. And we did this via Chef. That was our main tool of choice here, was that we basically wrote a ton of tooling in Chef that abstracted away a lot of the primitives that a lot of these cloud providers provide, things like security groups and other hosted database services. We don't use any of those because we just use Chef to abstract all that away. And then eventually it actually did help in pricing. So my procurement manager was happier with me when I could go to her and say, like, hey, now we're spending a couple $100,000 a month and not a couple thousand a month. And we were able to go back to each of the cloud providers and say, hey, you know, the other one is giving us more favorable pricing. What can you do for me? And it actually did help. Are there any pricing experts from Azure or AWS here? Okay, good. Sorry, I probably should have had a disclaimer to kick people out of the talk. If you're a lawyer at one of these companies, please get out. Just kidding. I love lawyers. They're great. They keep me out of jail. Another interesting one was the engineering culture benefits, and this was something that we didn't really anticipate. This was this really nice side effect that we had. The folks from Gremlin were talking about chaos engineering aspects yesterday. So one interesting thing was that teams built for reliability very early in their software development lifecycle. So that didn't mean that they made everything completely HA from the beginning, but they made sure that they didn't back themselves into a corner and use brittle HA techniques. They knew that at some point they're going to have to deploy their service across this very distributed infrastructure, so they knew that they had to care about reliability from a very early standpoint. The other piece was teams had deep expertise in their technical stacks, and I'll go into a little bit more later, but this is a double-edged sword. But to all of our engineers at PagerDuty, there's no such thing as a black box. There's no such thing as well, the packet went in and it didn't come out and I'll give up. No. To all of our engineers, they had to figure out at very deep level what's going on with their infrastructure, to the point where, you know, they're trying to figure out if they're trying to understand like disk I/O issues between the different providers, they could actually do that. Every single one of our engineers is capable of doing that. And then, like I was talking about earlier, failure injection and chaos engineering. One of the hardest parts of getting started with chaos engineering is getting that kind of that cultural buy-in, because it sounds so counterintuitive. Hey, we're going to make things more reliable by breaking a bunch of stuff. Again, it just sounds very counterintuitive, and I know that's not actually how chaos engineering works. It's about injecting failure and doing very controlled experiments to understand where your bottlenecks and where your brittle parts of your stack are. But this was something that I effectively got for free as we were migrating to this kind of an infrastructure, because our engineers cared about it, because they saw the importance of it, especially when you're spread across multiple providers. So that's covering some of the benefits. Now the list that's a little bit longer is what didn't go so well, and kind of what did we learn in the meantime. Right sizing. Right sizing is really, really, really hard when you're spread across multiple providers, because you don't have the equivalent compute type. So we had this giant config file across our infrastructure that tells us what matches up from AWS to Azure. So and we get pinned to the limiting system resource. So for us, an AWS M3.large equals an Azure standard F4. And I don't expect any of you to know exactly what that is, but basically it's about an 8 gig machine and a 2-core machine, which is not equivalent to an 8 gig machine and a 4-core machine, which unfortunately means we end up paying a little bit more than I'd like for that 4 cores. And again, we should be paying more because there's more compute there. But the problem was we kept running into issues where we're trying to match the infrastructure across providers, and naturally they're not equivalent. And so we end up paying more for the infrastructure because we're pinned to that limiting system resource. Another piece, and I talked about this earlier, was the deep technical expertise required on every single one of our engineering teams. And here's a couple of examples where all of our engineering teams are having to learn at a very deep level about every part of their stack. One is that because they're forced to use just the common compute across all the providers, they have to spin everything up themselves. Things like load balancers, databases, applications, and HA systems. All of my engineering teams are responsible for that, and that's a lot. And look, I'm sure every single one of you in the audience right now has the most well-rounded engineering team. You have the best staff team. You have every skill set you need on that. Said no engineering manager ever. Every single engineering team out there is missing some skill set, some capacity, something on the team. And when you have to develop this level of deep technical expertise, it's really expensive. And it's something that can be very, very brittle, especially when someone leaves and all of a sudden you need to scramble to figure out, whoa, we just lost our database expertise. How are we going to do this now? Because you're not outsourcing that to your cloud provider. At PagerDuty, the way I won't say we got around this was we hired subject matter experts, so specifically around databases. We hired an individual named Luis who he came in, he took a kind of inventory of the land and decided, okay, here's the 7 things I need to teach to everyone. And that's how we got around it, was just a lot of internal training and a lot of internal education, because we weren't using things like the hosted database products that these cloud providers offer. The last bit, and this in particularly affected my site reliability engineering team, was the complexity overhead. And this was something that we really underestimated. We tried to treat everything like compute, and we thought that would actually make the infrastructure simpler to operate, but it actually made it a lot more complicated. And like I said, we tried to abstract away the providers via Chef. And the idea and the intent was, to the rest of the engineering organization, my SRE team, they would go in and they'd write a bunch of Chef code such that when another engineer connected to one of their servers, they didn't actually know where it was deployed because it all kind of looked the same to them. But and again, this is a very crude way of measuring it, but all I searched was like if Azure in our Chef code base and if AWS, and it's something like 50 and 180 mentions where there's a code block in there that says if this provider do this. So if we were to add another provider to this, there'd probably be somewhere between 50 to 100 custom code paths that we have to instrument in Chef for this. Again, this is something that we didn't really realize up front, and it's something that hindsight 2020, I wish we had been more mindful of how different the APIs are, how different the instance sizing is across these different providers. And not that any of them are right or wrong, it's just different. And to make that, to reduce that cognitive overhead to the rest of our engineering teams, we had to deal with that complexity. Even less control over the network. This is something that every single engineering team I know that operates any infrastructure at scale and a cloud provider, this is the #1 thing they complain about, is how little control they have over their network. And so, I have a couple of really funny stories here. One was we discovered in a very unintentional way where one of the providers had a NAT timeout. And so what that meant was, as we were doing larger and larger deploys, I think the timeout was 2 minutes, and we all of a sudden started seeing where, as we're copying the files over to the host, that after 2 minutes, the connection gets terminated. And it took us forever to figure out what was going on. We saw that it was only happening in one of the providers, and we reached out to the support team for that provider, and they said, like, yeah, it's a 2-minute NAT timeout. That's why your connection's getting severed. Again, great that they helped us, but that was another difference that we had to manage around, and we had to redo our deployment methodology as a result of that. Another one is some of the providers block ICMP for security purposes. Again, not a bad thing. It's totally acceptable, and that's something that the provider is fully empowered to do. But that broke our network monitoring that we had with the rest of the infrastructure. So what that meant was, for the rest of our engineering teams, if they're trying to troubleshoot some network issue, they couldn't do it in one of the providers. Here was another fun one. This is about a year and a half ago. AWS had a leaky BGP route between AWS West 1 and West 2, and our packets started getting routed via Japan. So we all of a sudden 10x latency, and there's nothing we can do about it. Another great one was between AWS West 2, and this is in 2015, AWS West 2 and Azure Fresno, we saw our throughput go from tens of megabits per second down to kilobits. And shout out, I don't know if anyone here is from Hurricane Electric, but they had the most fantastic knock there. So we emailed them saying, hey, we see that it's going over your network and it's really slow. Can you folks help us out? And like 10 minutes later, they fixed it. So thank you, Hurricane Electric. I love you folks. They're incredibly efficient at resolving these things. This was great. I don't know if folks remember this, but basically there was a fellow with a shovel that was making my life hell in 2015 because he's just going around cutting fiber links in Northern California. I don't know if they ever caught the guy. Actually, for this presentation, we have in the Bay Area, you can actually reach out to the FBI, like, if there's like cyber attacks. So I emailed them. I was like, hey, did you ever catch this guy? And the response was, cannot comment, we'll report back later. So I don't know what's happening there. Maybe we'll see something in the news later this year. I'm hoping they caught this guy. But the point I'm trying to get here is that the more distributed, the more spread out your infrastructure is, any goofus with a shovel can make your life hell. And for things like if you were just within AWS, across the regions, they have dedicated links. They maintain them themselves. They do a great job of laying down that fiber. Azure does the same exact thing. It's great. If you're staying within their infrastructure, you don't have to worry as much about this. But the second you have to go over this scary thing known as the public internet, you're screwed, because you have to now think about all the network links as your infrastructure gets more and more spread apart. So the other piece here is not being able to use the hosted services. And this is where, again, hindsight 2020, for a lot of our internal services that don't have the same HA requirements that other parts of our product do, I wish we were using things like the hosted document store in Azure, or we were using RDS in AWS. Those products have simply gotten better and better and better over the last couple years, and especially compared to 2012, they've gotten substantially better. And because of that, we were building, we run our own MySQL clusters and everything, and we don't just get to click a button and spin up an RDS instance. And because of that, there's an opportunity cost to that. Our engineers are having to spend more and more time running their own databases instead of building more functionality for our customers. So the big question that I'm sure many of you are thinking about, should you go multi-cloud? I get this question a lot from companies of all sizes, small startups all the way through to big companies. And like I said earlier, I'm going to give you the very disappointing answer of, it depends. I find the older I get, I'm saying this more and more to more people. And it's not because I'm trying to whiffle off on an answer, but for us going multi-cloud, it was that latency requirement and that reliability requirement that I talked about. And I guarantee you, not all of you have that, and that's okay. That's not a bad or a good thing. It's just you don't have that. So things that I would like you to consider if you are thinking about going down this route of multi-cloud, the first is think about the business requirements first and the technical requirements second. This is a mistake I see a lot of engineers make, where they see some technology and they think, oh, it's going to solve all of our problems. And the first thing I always challenge back to them is, well, what's your business requirement? For us at PagerDuty, it was minutes of downtime being unacceptable for our customers. That was the requirement that we have for the business, and then we had to go find a technical solution that would meet that. Another big piece here is having company buy-in. This is not a trivial investment. No matter what any vendor out there tells you that you can just run workloads across multiple clouds easily, it's complete BS. It is complicated, it is very, very complex, and it's not easy. Vendors can make it easier, but it's not trivial to do this. And so if you're going to go down this path, make sure you have the right executive sponsorship, stakeholder sponsorship, whoever you need to convince before you go down this path, because if you don't, what's going to happen is a year and a half in, folks are going to be wondering, why the heck are we spending all this time writing these abstraction layers instead of building something else? Engineering staff capabilities. This is something I referenced earlier, but be mindful if you have an engineering staff that can actually support something like this. This is a very complex beast that is not for everyone, and if you don't have what I would call those very low-level type engineers that are willing to get really deep into the nitty-gritty of your technical stacks, this is a lot harder because they're going to have to start doing that the second you go multi-cloud. And the last thing is, what do your customers care about? Again, it may sound interesting, it may sound crazy and sexy to do these things, but if your customers don't care about it, why are you doing it? And that's something to be mindful of as well. Your customers probably don't care that you're multi-cloud. They care about your reliability and availability, and there's probably other ways you can achieve that as well. This is one of my favorite quotes that one of our founders at PagerDuty told me years ago. And it was this the idea of understanding your customers' problems better than they do. And back then in 2012, our multi-cloud strategy that's what it was based on. It was based on us spending time with our customers, really trying to understand what they cared about in the context of availability and reliability. And that's why we went down this path. But if we didn't spend the time and effort to figure out what our customers actually cared about, I don't think we would have been able to make a very data-driven decision. I think we would have just made a decision and just kind of run with it, which doesn't really make sense, especially when you're spending millions or tens of millions of dollars a year on this kind of infrastructure. That's all I got, folks. Thank you to all of you for showing up. Also, thank you to, if you see anyone with an organizing or if they're part of the committee for the conference, please thank them as well. SREcon is one of the few conferences that I've been to where it goes really, really smoothly. And if there's any group of individuals that should appreciate things going smoothly, it's this group. So please thank them when you see them. And with that, I will open up to questions. Crap.
You mentioned that you can't use RDS in some of the hosted services that have gotten better and better.
Yep.
Have there been any discussions on your team about moving the abstraction layer up the stack, so maybe you're just using SQL or just using like those services, but kind of the purest form of, or least common functionality among them? Is that possible? And have you? Yeah,
we actually initially thought about the idea of going down the path of building an abstraction layer on top of not just Cassandra but also MySQL. And after about probably a week's worth of investigation of like how much that would cost us, we basically said this basically looks like writing your own database. And if there's if you listen to anyone on Twitter, they'll tell you don't write your own database. And so we did go down that path, but we immediately dismissed it because it was just too expensive to maintain that. Yeah, good question. Other questions? Oh, see someone running up. Oh, see two people. Duke it out.
You had mentioned not using provider-specific services like load balancers, et cetera. How many of those were you using before you adopted a multi-cloud strategy?
Quite a few, actually. So we were using, I know we were using AWS's ELB product. We were also using, gosh, there was something else, Elastic IPs as well. So there was quite a few things we were using within the AWS infrastructure. And then when we were deployed across AWS and Azure, we had to get rid of them. We basically had to start. We rolled our own Nginx load balancers. We just got rid of the Elastic IPs and said nope, just use DNS to do the lookup instead. So yeah, but quite a bit. We actually had to put quite an amount of effort into untangling that. Good question. Yep.
Nice talk, by the way. Thank you.
Thank you.
What do you use to configure individual providers?
So we use Chef very heavily still. So that's where there's a bunch of the custom Chef code that we have, and then we're just making API calls via our Chef code base. We are moving more of that to Terraform these days because Terraform has just better abstractions in place. So hopefully it's less for us to maintain. But primarily Chef right now is what we're using. So
you were launching instances from Chef.
Yeah. So we, in Chef, it's either Knife EC2 Create, and I forget the Azure equivalent, but I think it's Knife Azure Create, and that's what we're using. To credit to the Chef folks, they've done a great job of abstracting away some of those API calls, and that makes it a little bit easier.
Okay, thanks.
Mm-hmm. Hi.
Hey, you said at the start that you originally went multi-cloud because it was too complicated to handle the extra latency.
Yeah.
With hindsight, are you glad you made that decision?
That's a great question. It's a great question. In hindsight, I wish we had spent more time making our software more network failure tolerant. I think that was something that we underestimated how unstable and how flaky going over the public internet was going to be. And I think if we had known at the time how unstable it was going to be, I would have advocated more for let's just make our software more resilient. At the time, we felt that making the software more resilient to network failures wasn't worth the effort. So Yeah, hindsight 2020. I wish we had spent more time on that, or at least spent more time to figure out how much it really would have cost us. Yeah. Wow. Now I need to go talk to my managers about this. Any other questions, folks? All right. Well, if folks do have additional questions, I'll be hanging out up here, but feel free to reach out on Twitter or email me at arup@pagerduty.com. Thanks, folks.